Thanks. So my name's Erik. That's me. So I'm an engineering manager at PayPal, and I think Dan alluded to it earlier in his talk. We've been working with Node for a couple of years now, getting it as a first-class platform to build applications. So I'm going to talk a little bit tonight about Node.js at scale. And I know that that's a little bit ambiguous. I think Node.js at scale, what does that mean? And in fact, for getting Node into PayPal, it meant a lot of things. But I think the main things that it meant for us were scaling across 3 different dimensions. It wasn't just technology. It wasn't like, oh, we can pick a technology and just roll it out, everybody use it, we'll build awesome products, and Bob's your uncle. You just move on from there. What it actually meant was that we needed to figure out how to scale Node again across people, educate a whole lot of people in JavaScript and Node best practices. And that meant transforming C++ and Java developers into JavaScript developers and Node developers, as well as bring front-end engineers who are well-versed in JavaScript, but didn't necessarily have a lot of experience building server-side stuff in Node and understanding the Node ecosystem and what it really meant to build applications in Node. It also meant that we needed to look at our processes. A lot of processes were defined around Java, around other stacks, and were built specifically for those stacks, where when you brought Node, there wasn't really an analogous, a proper fit. So what did that mean for how our processes were built over time? And then finally, we could really address the technology and see how can we integrate Node into a lot of proprietary stuff that we run and a lot of not proprietary stuff, and where we could take advantage of what teams have done before and where we need to forge new ground. But unfortunately, when you come to talks like this, people just want to see technology. They want to see code. But I think one of the better things about the Node community and about how you think about software and you build software in Node is that it's only partially the technology. A big portion of it is around bringing new people into the fold, bringing new engineers into understanding how to write JavaScript and Node JavaScript, and mentorship. And that's, I think, one of the most interesting things about the community for me is that there's a very concerted effort put towards bringing in people that either don't know how to write code in general or just never tried it, and embracing them and saying that this is something that's for everybody and you can build awesome stuff. And Dan had mentioned things like Node bots, the Internet of Things. Like, people can build stuff, build anything they want with a very arguably straightforward language. I don't know if you want to start that. Yeah, really. But it's approachable, and the Node community has made it more approachable, in my opinion. So even though that the first 2 phases are kind of the boring part because people want technology, I'm going to talk about them a little bit, at least how they pertain to PayPal and some of the things that we've worked through. So first of all, scaling people. And when you say it like that, it sounds real weird, but it's about growing people, and it's about educating people and making people comfortable working in this environment. So there's the old analogy, teach a person to fish, or give a person a fish, they eat for a day, teach whatever. It was very coincidental that while writing this, I remembered that my buddy John Charles wrote this bot that slaps people with trouts for Slack. It was very strange. This isn't to indicate that I actually taught John Charles anything. He actually teaches me stuff every day. But it was something that reminded me, like, when you have a team that's tight-knit and people teach each other all the time, it's just an incredible ecosystem in which you can grow and your team can grow, and you can do things like slap each other with fish over Slack. It's pretty awesome. But that's all to say that writing code isn't enough. And in the macro level at PayPal, when we had to train hundreds of engineers, that's one thing. But then now I'm a relatively new engineering manager. I realized that it's not enough just to put them in classrooms and say, learn this stuff and let's go turn out stuff. It's really important, and again, I'm going to tie this back to the Node community, that there's this notion of mentorship, and there's this notion of helping everyone around you grow, because when everybody grows, the whole ecosystem grows. So just kind of a wrap up to the people thing, something that I've instituted in my team, and I'm hoping to be able to roll out to other teams in PayPal, is kind of this 2-phased approach. And if anybody likes the idea, wants to try it on their team, that'd be incredible. One is riffing off of the Learn You concept. Is every week I allocate for my team a certain amount of time to learn a new technology. It doesn't matter what it is. Just learn something, because anything you learn can be somehow applied back to your everyday work. So we do things like learning Elm, like learning Rust, like learning Angular, any front-end frameworks, React.js, that type of stuff. And then we talk about it at the end of the week. We see how can some of these concepts feed back into how we work with Node, how we work with other organizations around or teams around the company, and what that looks like. And then, so that's every other week. And then the alternating weeks, I've challenged my team to contribute code to some project that either you're passionate about or you use on a regular basis. And this is something that's been huge in the Node community for me, and it's directly taught me how I can not only contribute just by putting my own code out there, but I can contribute by reading other people's code, understanding how other people solve problems, and then taking that and wrapping that, either contribute directly to that or wrapping that into how I solve problems and ultimately build better software. So as far as wrapping up the growing people aspect of it, I think there are very constructive ways you can help your team directly contribute to the Node community, which is exceedingly embraces anybody who wants to contribute, but also add value to them personally and your team as a whole and make your team just operate better. So moving on from that, the second point, the second boring point, I guess, is scaling process. And this is not to indicate that process always has to scale up. In our case, actually, process is scaled down. And Node was one of those factors, and in fact, it was a bit of a catalyst for some of the things that scaled down. So I'm going to talk about a couple of specific things that happened for us at PayPal. This is not to say that JVM expertise isn't important. In my experience, I've observed that sometimes there are JVM experts that exist merely to wallpaper over the fact that engineers don't necessarily pay attention to performance when they build applications. Performance is a value add by another organization after an application gets built. That can't hold true with Node. Engineers need to understand the consequences of the decisions when they write software. They need to understand, maybe not quite to the level of Trevor. That's pretty awesome, but I don't know that it's generally applicable. But they definitely need to understand that when I'm writing code, when I'm interacting with a network resource, with the file system, doing anything, just we were talking about maybe some system level stuff isn't the right fit for Node. Engineers need to understand that there are certain consequences of decisions and that there are some things that are not a natural fit, but that's okay. I don't think it's right to expect that engineers can just bang out code and then somebody else can clean up after them. So I think part of the process thing is making the process of educating engineers, understanding that there are consequences of decisions and that right design is right design. That doesn't even make sense. But that thinking about design before you start coding has a meaningful impact, and you can still build great software, and you don't have to have these other guys that come along and clean up for people that just need to meet deadlines and just, I don't know, check things off their list. So that leads me on to the next thing, and this is not an anti-Java thing. This is just from multiple Java shops that I've worked at. I've really seen that if you have platforms that take a lot of time to deploy and a lot of time for applications to start and a lot of time to prime caches and a lot of time to do all this stuff, you start designing your system to have to avoid doing things like restarts. And one of the things that the Node community embraces, and it's generally by virtue of the fact that you have small processes and very discrete things that applications are intended to do, you no longer have to worry about accommodating 10-minute, 15-minute startup times. You can write applications that are very good at that thing that they do, and they can be resilient to some types of situations, but they can also fail and restart very quickly and take traffic without much of a hiccup, if any. And this is really just about controlling complexity. There's nothing wrong with hot swapping things, about flushing caches and reloading caches. It's not a bad design. In a lot of cases, that's good design. But there are so many times that complexity is added to counter problems elsewhere in your stack, like it takes 10 minutes, 15 minutes for applications to start up. that all, notwithstanding that, especially for developer experiences, if your app takes 10 minutes to start up just when a developer is trying to do their work, they're not going to get anything done during the day, especially when you talk about the back end and front ends, where engineers are trying to write HTML, JavaScript, and CSS, but they're bound by, I got to bounce my server because I made a change. That changes the payload that I need, and now I can go take a coffee break. And then the last kind of big thing that, I guess it's not the last, next to last kind of major thing that I've noticed, which I think Node has been a little bit of a catalyst for, but it was already happening to a certain extent, is, and again, this is a PayPal, probably somewhat specific to PayPal. For people at small organizations, you probably don't run into this. But there can be a lot of layers between you and where your code is actually running in production. There can be situations where you hand off some artifact, and then it goes into a black box, and you find out, okay, it's running in production. Go check this system to find out how it's performing or whatever. And there's been an incredible, relating back to specifically at PayPal, this great renaissance of developers have the control of their own destiny. They have control of their deployment. They have control of the code that goes out. They understand all of the processes, all the steps that happen between when they're ready, they build their artifact, they deploy it, it runs. They can see everything in that process. And it gives them a lot more freedom to understand, again, tying it back to the understanding what your code is doing in production and having ownership over things like performance. When you can see that transparently and you don't have these layers in between you and your code, it's really easy to feel empowered to do something about it. And then finally, this is, I don't know if it's a process thing, I don't know what it is, but moving from Maven to NPM is kind of a big, it's kind of awesome. And there's a little shout out in there to Kappa. So at PayPal, we run, we haven't yet migrated or done the beta test for NPM Enterprise. So in the meantime, we've run our own registry, and we use a thing we wrote called Kappa to proxy requests. So we publish all of our private modules to one NPM registry, and then Kappa will check that registry for a module. If it doesn't exist, it'll then check public, which gives us nice separation between where our proprietary code lives and public NPM. And it turns out that for a lot of use cases, that's really good. And in fact, for us, excuse me, just to kind of get an idea of the scale that people are working in Node at PayPal, right now, Kappa is serving, and it may be up because I just grabbed this number about a week and a half ago. We're serving about 500,000 pages, sorry, 500,000 packages, Node modules per day through our private Kappa instance. So there's a lot of installs, NPMIs going on. There's a lot of builds going on that are installing packages. And there's a lot of people that are publishing packages to our private registry. So I think, you know, it's been a really interesting observation to see how processes, these big processes that put a lot of people between you and where your code goes, have started to erode to support being able to iterate quickly, like Dan said, to be able to observe and understand performance implications, and really just build applications very, very quickly. And in a lot of cases, fairly robustly. These applications are pretty good. So finally, scaling, now the technology part, which probably everybody is here to talk about or hear about. So scaling Node.js. So I doubt anybody knows me personally from my involvement in the Node community. Maybe some do, but PayPal had introduced, it's been a while now, maybe a year and a half, this kind of frameworky thing that sits on top of Express called Kraken.js. So Kraken.js was our attempt to help scale Node across our organization, not from a performance perspective, but take some of the tribal knowledge out of setting up web application servers and make it a repeatable process that you could have a predictable application by default and let application developers focus on building great products and not think about wiring up all the low-level details that it takes to just get a baseline robust server going. So, so that happened about a year and a half ago. We're definitely making progress. We're not still stuck there. Right now, we have about 30 web applications running in production. Some notable examples are our homepage. It's not yet at 100% traffic, but they're ramping up right now. Interesting kind of hand-wavy stat that only because I don't think I can say actual numbers is that they're on a trajectory to use about half the number of servers that were needed for the previous version that was written in Java, which is a pretty awesome feat, especially since traffic has grown since we were running in Java before. And that's actually prior to any optimization passes. They're right now at the point where they're running optimization passes over their application and focusing on very specific bottlenecks. So that's been a really encouraging thing. Things like the consumer or customer homepage, my account page, and you log in, 100% US. I think I wrote it down, maybe not. US, UK, and Germany, I think, 100% of traffic all running on Node. So we've got, a couple of applications running on Node. We've got a couple of people that know how to write apps. We've been able to scale it pretty well, but there's definitely been hiccups along the way. And I'm not sure, I'm going to say it, that I think other than actual programming errors, the lion's share of issues that you run into with scaling Node all come back to some form of back pressure. Whether it's CPU constraints that you have, it's basically resource constraints based on decisions that you make. So I have a lot of network connections, and my downstream services can't handle the load. So I consume resources just by virtue of the fact that I have thousands of concurrent connections open, or I'm doing a lot of template rendering, like Trevor mentioned. So my CPU is bound by some work that I'm doing that really has nothing to do with my core business value. It's just something that's a side effect of needing to render pages or whatever. So one of the things that we're trying to focus on is finding ways to address those bottlenecks and allow teams to still build applications quickly, but help fix some of those potential pitfalls of back pressure. So one of the things that I've been working on recently that hopefully is going to be rolled out is this module called Levy. Now we're going to get into code a little bit. So if anybody's familiar with the circuit breaker pattern, this is based off of actually an existing module out there, and I'm going to look at his name quickly. Well, I guess I can't. I'm not going to bounce out of this. There is a Node circuit breaker module that this is heavily influenced by. It's really good. I just had another direction that I wanted to take, so I decided to try my hand at it. But what a circuit breaker pattern is if I have an application that's talking to services, actually before I go on with that, circuit breaker in Node, and actually Netflix's Hystrix is a Java JVM-based implementation of this same pattern, which is pretty awesome. So this is just my crack at making it for Node. But basically, if I have a service that exceeds its SLA on the client, I can observe, let's say I have 5 requests timeout. I can actually trip this circuit breaker and put it into an open state, meaning I will fast fail subsequent connections for a certain amount of time. After a certain amount of time has elapsed, I will allow a single request through as kind of a smoke test to see if that application is recovered. If it has, great, the breaker closes and I resume traffic. If it hasn't, I go ahead and reset, and then after a certain amount of time, I try again. So this is a really interesting way of dealing with back pressure, where instead of just timing out and keeping a ton of connections open, or the application goes down and I just get thousands of econ reset errors, I can actually set up a fallback mechanism that allows me to put in a fake payload or some sort of message that I can use for my internal clients or my code in my application, but also doesn't repeatedly hammer my APIs or my services such that they can't recover. It takes the traffic burden away from them. So if they need to be restarted or if they're just slowing down because they can't handle that traffic, it gives them that built-in recovery time. So a quick, just very fast example of this is, so this is an example using the rec module by the Happy.js crew, Aaron Hammer. So normally you just write rec.get, and you got this thing called downtime because it's not up very often. And you get back after calling, you're getting your stats. You get an error, you get a response, and then you get the payload. So with Levy, I grayed out the stuff that doesn't change. You can wrap the get call in this create breaker. So you have this circuit breaker instance. So now you can call the same API, circuit.run, and you give it the call. And after a certain number of failures in this particular configuration, you'll still get an error message, but after those failures, the error message will say, I'm not calling that anymore. I'm just fast failing because the service is down and there's nothing I can do, and it doesn't make sense for me to use resources and keep connections open on a service that may take 5 or 10 minutes to return or just be down. So that's the first pass. But then the second pass is I can configure a fallback now. So if I had this create breaker before, I can then create a fallback that is always successful. So I don't have to then think about, well, what if it's down, I get error messages back. I may get a few error messages at the beginning until I hit that threshold, but after that, I've got a backup payload that will suffice for running my application, or at least notifying the rest of my application that this service is down for a certain amount of time. So again, this is something that we're going to be trying out at PayPal. Netflix has used this pattern with great success. And I think, when we're talking about Node and we're talking about performance, talking about back pressure being a major issue. I mean, even if you talk to the Walmart guys on Black Friday, like the Node process isn't the problem. It's the fact that it can send traffic so fast to other applications that may not be able to deal with that amount of traffic. That could potentially become the issue. So I'm a big fan of the circuit breaker pattern. I'm going to run through these next two things really quickly because I'm going a little over, but Dan briefly talked about APIs and about REST APIs and REST specifications. So another thing that a guy on my team is working on, Trevor Livingston, is this thing called Swaggerized Express. And it's a spec-first approach to building services, to building RESTful services. So at PayPal, part of the process of building a service is you define the API for that service, and you iterate on that design before you start writing code, which is really boring for people that like to write code. But on the other hand, what that means is you have a document that is the canonical representation of your API, from which documentation falls out, from which your implementation can fall out, and from which client APIs or client modules can fall out. So when we thought about it, we thought, all right, well, everybody's spending this time putting effort into building this document. How about we use that document to not only drive the generation of these apps, but then drive the validation of these endpoints, the validation of the inputs and the outputs, and continue to use that document as a canonical resource to describe the API for both clients and servers, but then also to help ensure that these apps are stable when they're being built, and then when they're running in production. So just a quick snippet of code. It doesn't really describe much, but it has, basically, you just use it with Express right now. The API JSON is your Swagger document that describes your API. This assumes that you've already run the generation step and you've built out the scaffolding for the API. You have a reference to your handlers and then a reference to your documentation. And then finally, it's a working name. I don't think Purnima has come up with I think we're still working on the name for it right now. But another thing that we've observed when running applications in production, specifically web applications, is that it's important to instrument your app to understand what it's doing in production, but more importantly is instrumenting your app to understand what business value it's adding, which means that you're potentially doing a lot more logging of specific data as it pertains to what's flowing through the app. Not is my app healthy, how much memory it's using, but is my app actually fulfilling the metrics that the product team has established for what it should be doing. So when you're talking about doing a lot of logging, we have a lot of services that are socket-based, that are REST-based. I guess none of that matters. What matters is, what we've observed is people will either write these giant JSON objects, or they'll write a lot of code to pluck individual values out of these gigantic payloads in order to do this type of reporting. And some teams just hand roll this property on this property on this property, and they write this really brittle thing that traverses this giant JSON structure. Some teams use an existing implementation of JSON path, which unfortunately is the source of some CPU contention, very heavily regular expression-based implementation, and also does this parsing of the selector and the evaluation of the data in the same step. So what Purnima came up with was something that breaks that into two steps, and you use the selector to compile an evaluator, and then at runtime you run the evaluator over your object, meaning that we can get these giant payloads back, JSON payloads back from our services. We can write a selector that plucks off individual values from that payload, and then just logs what it needs with as little CPU overhead as possible, and more importantly, less brittle logging code spread all over our application. So that's just a quick example of transposer.create. So you created your implementation based on the selector, and then at runtime, you just run it over the data that you want. And just a couple of stats for what she's been able to do with it. The existing implementation that the team was using so this is recursively select any property with a name ID is what this top one is. She's been able to improve it. This is her module. This is the existing module. And we're hoping that, again, bringing that back to the Node.js at scale, to be able to grab data at runtime, do logging without any or minimal effect to the customer experience. Hopefully this will help us get that far. But anyway, so that's all I have. Kind of rambly and quick, but hopefully, it gave everybody some insight into kind of how we've been able to scale Node at PayPal.
All right. Thank you, Erik. Cool. So Guillermo is just getting mic'd up here. Once again, so another about half an hour, take a quick break after that, and then we'll do the Q&A with all the speakers. Are there any quick questions for Erik while we're setting up? Erik, come on back. Any quick questions here? Yep, go for it.
Yeah, so you mentioned a little bit seeing like a performance increase moving to Node. You were kind of talking about like less servers, things
Yep.
like that. I guess that kind of baffles me a little bit, like moving from JVM to Node and seeing a performance increase. What do you ascribe that to? Like, is that?
Repeat the question.
So the question was, I had given this kind of high-level statistics of it's been taking less machines to drive the Node implementation of a particular application than it had the JVM. The specific thing that I attribute that to is that the application did not a ton of business logic, but really the logic was around composing pages. So it was very amenable to large caches and just literally writing buffers out to the response. It made some service calls, not as many as our other heavyweight applications, but the fact that it's a small plug to Kraken, but the fact that it's based on a very lightweight thing instead of, to say that it's faster than JVM makes a lot of assumptions, right? Like you have frameworks built on top of frameworks in any platform. For our particular implementation, the fact that Kraken was lightweight for what they needed based on Express, that it was it didn't provide any features they didn't need. It just inherently had a lot of less overhead to do that specific task. It wasn't necessarily, it was, it could mostly be attributed to our implementation on top of the JVM, but it was just an observation that for our business, half the servers is half the servers. You can't, it is what it is. But it was a little hand-wavy, I agree. And it really depends on your implementation. It depends on the stack that you build within your organization. But as a direct port for us, it was a really big win, at the end of the day. So, cool. All right.